Hello, this is Dr. Mahesh Kalyanshetti, Associate Professor, Department of Civil Engineering, Walchand Technology, Solapur. Today we'll discuss about the compaction of soil, where we focus on modified Proctor test. The learning outcome will be at the end of this session, students will be able to describe the modified Proctor compaction test of soil and its associated properties. The compaction of soil is defined as a process by which soil particles are artificially rearranged and packed together into a state of closer contact by mechanical means so that the porosity of the soil will decrease and it will result into increase in the dry density. Now, for many civil engineering purposes such as highways, buildings or retaining water constructions or earth dam, we need a soil material which shall possess certain properties while these are placed at the given location. Now, these desirable features can be achieved by proper placement of an appropriate soil material, and most of these desirable qualities of the soil are associated with high unit weight, which will be achieved by the compaction. The degree of compaction of a soil is characterized by its dry density. The degree of compaction depends upon the many factors, but the important factors are the moisture content and the compactive energy which we apply to the soil. A change in moisture content or compactive efforts brings about a change in density. Thus, for compaction of the soil, we need to have certain amount of water in the soil mass, and also we need to apply some predetermined amount of compacting energy. The effects of the compaction are shown here. See, the compaction increases the dry density of the soil, which will ultimately increase its shear strength and bearing capacity of the soil. Compaction also decreases the tendency of the settlement of the soil, and compaction brings about a low permeability of the soil. So, these are the desirable properties of the soil which are placed at the given location, and if the soil has to perform well, it shall have a good bearing capacity, it shall not have a tendency for the settlement, and it should also have a very low permeability. So, ultimately we can say that to ensure the better performance of the soil on the field, there has to be a proper compaction of the soil mass. The compaction phenomena is explained in this particular slide, wherein we see that there is a typical curve shown on this particular diagram. The x-axis we can plot the moisture content, on y-axis there is a dry density, which shows that with the increase in the moisture content, the dry density of the soil goes on increasing initially, and then later it starts reducing down. And this particular curve we can obtain in the laboratory. So, this particular phenomena is been explained here with the help of these 5 diagrams. As in the left hand side, we can see the first diagram shows a typical 3-phase system where there is a soil solid, water and air, which is shown in the 3-phase system separately by a solid, water and air. So, initially when we start the compaction, we have a certain amount of solid, certain quantity of water and majority of the air. So, this particular state is been represented here on the graph paper. It has got certain amount of dry density and certain amount of moisture content. So, when you apply the compacting energy to this particular soil mass, then the air will get released, and since for the compaction we need to add certain amount of water in it. Therefore, in the second trial what has happened is the water content has increased and the volume of air has decreased, and ultimately it has led to decrease in the volume of the soil mass. So, the mass increases and the volume decreases, therefore, the density increases, and simultaneously as the moisture content is more than the previous trial, the water content also is high. So, the second point we can see here the dry density has increased and the moisture content also has increased. Again, subsequently, if I go for the further compaction, the remaining amount of air also will get released, and there will be the water will get occupied in these particular voids. So the volume also goes on reducing, and since the volume further reduces, the dry density increases and water content is more than the previous, therefore the water content also is increased. So therefore we get a third point where we can see the increase in the dry density and moisture content. Thereafter, if I add a water to facilitate the compaction, so the volume is not available in the soil mass to accommodate this extra water, therefore the volume of the soil mass will increase. And since the volume of the soil mass increases, its density now reduces. And water continuously were increasing, therefore the water content will increase but dry density will decrease. And this is the reason why at the fourth point we see the decrease in the dry density whereas increase in the water content. So if you continue further, again the volume of the water will increase, subsequently it will increase the volume of the soil mass and it will decrease the dry density and water content goes on increasing. So fifth point shows that decrease in the dry density and increase in the water content. So in this way we can see that the soil dry density goes on increasing initially and it reaches to the maximum point and further it starts reducing, and we are continuously increasing the moisture content in the soil mass to facilitate the compaction. So we reach to one point where the density is maximum, that we call it as maximum dry density, and the corresponding water content at which we obtain this maximum density is called as optimum moisture content. Now this can be achieved in the laboratory. So different soil will have a different type of compaction curve. Therefore, whenever the soil mass is given to you, we need to perform the experiment and we have to find out the parameters. So there are two basically the compaction test. One is called as standard Proctor test, which also is called as light compaction test, and another is called as modified Proctor test, which is also called as heavy compaction test. So in the previous session I have covered the standard Proctor test, and in this particular session we will see what is the modified Proctor test. Now it is been observed that during World War II by the US Army Corps of Engineering, for a better representation of the compaction, they developed this particular method of compaction of the soil, which is called as modified compaction or heavy compaction. And for heavy compaction we need to refer the specific properties of the soil in the laboratory, wherein the soil mass is subjected to heavy compaction. So that's why this particular method we call it as modified Proctor test. Now in the compaction test, as it has been covered in the previous session, that we use the compaction mold, then there will be a collar and the rammer. And for standard compaction test, already I have explained in the previous session the specification of these all materials or these all accessories. Whereas in the modified Proctor test, there will be little change. So if I look at this particular comparison, so on the left hand side we have a standard Proctor test, all the specifications, and right hand side we have a modified Proctor test, all the specifications. In the standard Proctor test, we have the same mold, that is 945 centimeter cube. So you can see this particular mold, the same mold is used for both the test. And the major difference is that the height of fall of this particular weight. So this is a rammer wherein a specific amount of weight is being allowed to fall through a certain specific height. So for a standard Proctor test, this height is 305 mm, whereas for modified Proctor test, height of fall is 450 mm. Whereas the rammer weight also is different. For standard Proctor test, the rammer weight is 2.5 kg, whereas for modified Proctor test, the rammer weight is 4.9 kg. And there is a difference in the filling of the mold also. In the standard Proctor test, we fill the mold in 3 layers and each layer is given 25 blows. Whereas in the modified Proctor test, we fill the mold in 5 layers and each layer is given 25 blows. It means that we apply more energy in the modified Proctor test. And a summary is also given here. In the standard Proctor test, we apply 6065 kg centimeter per 1000 centimeter cube of soil. Whereas in modified Proctor test, we apply 27,260 kg centimeter energy per 1000 centimeter cube of soil. So after performing this experiment, we get a compaction curve, and I have shown here the typical compaction curve which are obtained by standard Proctor test and modified Proctor test. So these two particular compaction curves are obtained of the same type of soil. So if I follow the guidelines of the standard Proctor test, then I will get a compaction curve which is shown in red, where you can see a typical amount of maximum density we get and the corresponding water content we can obtain. Whereas the same soil, if I go for a modified Proctor test, it means if I apply the heavy compaction, then I can obtain the compaction curve as shown in green, where it has been very clearly indicated that the maximum dry density increases and optimum moisture content decreases. So in very important conclusion we can draw from these that due to application of heavy compaction, the maximum dry density and optimum moisture content will change, and because of the heavy compaction the dry density increases but optimum moisture content decreases. Now this is another zero air void line which is many times used to know the variation of the dry density with respect to water content for a zero air void. So if I assume the air voids to be zero in the soil, then the variation is being shown by this particular dotted line, and we can obtain this dotted line by obtaining the dry density corresponding to zero air void, which is determined from this formula, where Na is the percentage air void. So we can keep this Na value 0 for zero air void line, and such kind of zero air void line we can obtain. These are the references which are used for the presentation. Thank you.